Okay, this is section 1.1 for Math 131. We're going to start by talking about the natural numbers. Those are basically our counting numbers. So they start with 1, 2, 3, 4, etc. So you can see the pattern here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These dots are called ellipses. Okay. That means that the numbers just keep continuing that pattern. So the next one will be 9 and 10 and 11 and 12, etc. Okay? Those are called our natural numbers. Okay, the counting numbers, the natural numbers that are divisible by 2, are called our even counting numbers, which, as you probably know. So 2, 4, 6, 8, 10, 12, etc. Okay. The counting numbers, or the natural numbers that are not divisible by 2, are the odd numbers, and those are 1, 3, 5, 7, 9, 11, etc. So we have the odd counting numbers. Okay. And we talk about divisibility. We say if you divide A by B and your remainder is 0, then we say A is divisible by B. Okay? So we can say 6 is divisible by 2 because 6 divided by 2 equals 3, and there's a remainder of 0. So we can say 6 is divisible by 2. Okay. Or we could do the same thing. This is divided by the way. Okay. We could do the same thing with 6 divided by 3. We could say 6 is divisible by 3 because 6 divided by 3 is 2, remainder 0. Okay, next we're going to talk about inductive reasoning. And this is the process of reasoning to a general conclusion through observations. So it's reasoning through what you observed. Okay, and this is called induction. Okay. And we use it in the scientific community to predict answers to complicated problems by looking at observations. So inductive reasoning is part of what we call the scientific method. Okay. So we make a prediction based on observations. So prediction based on observations. Okay. That's called a hypothesis or a conjecture. Okay. When you make a prediction based on observations. One example of that would be the weather. You're looking at observations of weather patterns and then making a prediction based on what you've seen. Okay. Maybe you look at average temperatures from the previous year or from the previous month. Okay. So here's an example. What reasoning process has led to the conclusion that no two people have the same fingerprints, or no two people have the same DNA? Okay. Well, we base that on observations. Okay. So we've noticed through observations that no two people have the exact same fingerprints, or two people have the exact same DNA. So through millions of tests, we found that no two people have the same fingerprints or DNA. Okay, so this is by inductive reasoning or induction. Okay, so we believe that fingerprints and DNA provide a unique identification, and therefore we can use that in a court of law as evidence. Okay, now is it possible that sometime in the future two people will be found who have exactly the same fingerprints or DNA? Well, that's possible. We haven't found that yet. But that's sort of like the flaw of inductive reasoning, is that we're just basing observations. So we don't know. I mean, that could happen in the future. But as far as we know, no two people have the same DNA, no two people have the same fingerprints. Okay, that's inductive reasoning. Okay, let's look at an example where we pick a number and we first multiply that number by 4. Then we add 2 to that product. Then we divide that sum by 2. And then subtract 1 from that quotient. Okay, so let's say the number 2 we'll start with. Okay, so if we start with the number 2 and we multiply it by 4, so there's our first step. Okay, and then we're going to add 2 to that product. So now we're going to add, say, plus 2, and we get 10. Okay, and then we're going to divide that sum by 2. So divided by 2, and we get 5. Okay. And then we subtract 1. We get 4. Let's do it with a number. Let's do it with 3. Okay, so 3, sorry, I'm running out of space there, times 4 equals 12. Add 2. I get 14. Divide by 2 equals 7. Subtract 1 equals 6. Okay, so when I started with 2 and I did that, I got 4. And when I started with 3, I got 6. So what could we conclude about this procedure? Well, we could say, well, maybe it doubles the number. It looks like it might double the number. We're not sure, but we could say that as a conclusion, maybe by induction, that that's what that does. So here's an example where we took 5. Okay, so we start with 5, we multiply times 4, and we got 20. Then we added 2 to that 20, we got 22. Do divide by 2, and we got 11. And then we subtract 1, we got 10. And we go from 5 to 10. It looks like we're doubling the number, because we did it with 2 and 3 as well, and it doubled, right? So it looks like it's doubling the number. We would say, well, by induction, because we looked at observations, that's what it is. Okay, when we test a hypothesis or conjecture, if we find a special case that satisfies the conditions of the conjecture but produces a different result, in other words, it gives us a result that we weren't expecting, we call that a counterexample. Okay, and we only have to find one of these to disprove our conjecture. In other words, let's say I put in 7 with that previous procedure and I didn't get 14, I got 13. Then we can say, well, that thing doesn't always double the number, right? Because we found an exception. So we call that a counterexample, and that's an exception to the rule. And only one exception is necessary to prove the conjecture false. So just one there, okay? Only one exception, okay? If we can't find a counterexample, it doesn't mean we've proven it, it just means we haven't disproven it, okay? So you have to understand with inductive reasoning is that we're not really proving anything. We're only able to disprove by a counterexample. So if we haven't found a counterexample, we assume it's true, but we haven't proven it yet, okay? We have not proven that all DNA is unique. We have not proven that all fingerprints are unique. But we haven't disproven them because we haven't found a counterexample yet. So we use that as a way to determine someone's identity. Okay. The other type of reasoning we use is called deductive reasoning. Okay. Deductive reasoning or deduction. Okay. Now, that's the process of reasoning to a specific conclusion from a general statement. Okay. When we say general statement, we're proving it. We're showing that it works all the time. So we have to use an example that's general, okay, that works for every possibility. And we are actually proving our conjecture using deductive reasoning. So inductive reasoning uses observations and it's not proven. We can only disprove it. Deductive reasoning we can prove, okay. So for example, going back to our example 5, where we did that procedure with our numbers, we can do this with a number that represents any number, and that way we're proving it generally. Okay, that's deductive reasoning. Okay, so let's do that in the next slide. So we're going to start when we pick our number. We're not going to pick 1 or 2 or 3. We're going to pick a number called n. Now that just means n can represent any number. Now that means any number that represents a quantity. We call that a real number. Okay, and so we'll use n. We use a variable. Okay, and when the first thing we do is multiply by 4, right? So we take 4 times n, or we can write it as 4n. Okay, and then we're going to add 2 to that product. So we're taking 4n plus 2. Notice we can't do anything with this. We're just it's just hanging there, right? Because we don't know what n is, right? Okay. Now we're going to take that 4n plus 2 and divide by 2. Now when you do that, you're dividing the 4n by 2, and you're dividing the 2 by 2. So just to kind of do as a side here, we could write it like this: 4n plus 2 over 2, okay, and that equals 2n. Divide by 2 there, plus 1 divide by 2, 2 divide by 2. So we're dividing this 4n divided by 2, and then this 2 divided by 2 to get to 2n plus 1. Okay, and then the last thing we're doing is taking away 1. So we have the 2n plus 1, and we subtract 1. Now that cancels out this 1, so we're ending up with 2n. Okay? So we started with n, and we ended up with 2n. Now that's double whatever our number was, right? So we've proven that this procedure, this multiply by 4, add 2, divide by 2, subtract 1, always doubles the number that we start with, because we started with n and we end up with 2n, or 2 times n. Okay? So we've proven that this absolutely works for any number by deductive reasoning. Okay? So that's our deductive reasoning there. Okay? How we've proven that.